Okay, so welcome to Explosion Day. We're just gonna blow a bunch of crap up for a while. We're gonna have a couple big explosions, a couple small ones, but I want to give you the idea of what's happening. Why does a hand grenade explode? Why does gunpowder explode and push a bullet out? Why does this work? So, explosion theory. An explosion happens in a rigid container, something that can hold pressure. When pressure increases, how do you increase pressure? You can pop this balloon. We're gonna go back and show a methane gas explosion in this can. So how can we make it pop? Well, of course, you probably remember from your gas laws, Boyle, Charles, and Gay-Lussac's laws and stuff, that if you increase the temperature like this isn't technically a rigid container, obviously, but if you increase the temperature, the gas expands and expands, eventually to the point where it tears and pops. But I can also explode it by putting more particles here. If I blow it up more, blow more in there, there's like more particles. So either by getting the particles out of there hotter, or putting more particles in, it'll explode. So the methane explosion. I'll show this in a few minutes. The methane explosion itself, I just have this methane gas plus oxygen making water and carbon dioxide gas vapors, gas and gas. It's going to make a lot of gas. This is also gas in the first place, though. So let's balance this equation. I have a 2 there, a 1 there, and a 2 there. So I have 3 particles of gas turning into 3 particles of gas. Well, that doesn't change the moles at all. Okay, so it's 3 particles and 3 particles. 3 moles of particles and 3 moles of particles. So that doesn't change the moles, but it's going to go from a room temperature about 20 degrees Celsius up to like whatever it's going to be, like say 1,000 degrees Celsius. I don't know the exact temperature. Maybe it's only 800 degrees. Either way, it's going to be a lot. It's going to have a big change in temperature. So this can, which is rigid, pressure will build up and boom, blow the top off. We'll see that in a couple seconds here. So general commercial and military explosives. Now, how do they work so well? This is going to just be a little ploop. It's going to be pretty wimpy and stuff. If this balloon pops, it's pretty wimpy. But obviously, for like destroying buildings and stuff, when they force collapse buildings or doing mining and blowing huge chunks of ground apart and stuff, these commercial and military explosives are very, very intense. What you have is like your explosives, like the gunpowder, the C4, or whatever it is. You have a bunch of room temperature solids. So this is starting out gas to gas. Well, gas to gas doesn't really have much of an increase in volume. But if you're going from solid to very hot gases, just a solid to gas is like 500 times bigger volume. And then it's also going to be a couple dozen times hotter. So you have a huge volume increase going from solid to gas, and also a huge temperature increase. There's a lot more gas particles being made. So let's do some fun demonstrations. Okay, so we're going to take this can and fill it with methane gas. Stinky. And light it. Notice we don't get anything right away. We have to wait for it to burn down for a while. So there's too much methane in it now. It'll only build up pressure and explode if it has the right oxygen to methane mix. So right now there's too much methane in the can, but not enough oxygen. But as it burns off, there's a little hole in the bottom, and as it burns off, it's gonna burn off the methane on top and suck more oxygen in the hole in the bottom, and burn off more methane on top and suck more oxygen in the bottom. Burn off more methane on top, suck more oxygen in the bottom. And eventually it's going to be the right mix of oxygen inside that the flame can go back down inside, and then boom. So right now it's just burning off the top. It's about 1/2 inch right now. Getting lower, you can feel the tension build up. You know it's going to go. It's going to go eventually. Getting lower. It's like maybe 1/4 of an inch. Like when the flame basically disappears, the fire goes back inside, and then boom. Getting lower. It's like an 1/8 of an inch above the can right now. It's a super tiny little flame. Come on, do it. All right, so again, the can's not really hot right now. It's just a little bit above room temperature. It's so hot, it vented that, the flame was like 800 or 1,000 degrees inside, so it got super, super hot inside. but it blew all the hot air out, so the can is still basically room temperature right now. It's not really hot, but again, you see a little hole in the bottom. So it burned off the top, and as it burned the methane off the top, it sucked in oxygen in the hole. It was able to, able to pull in oxygen that way. And then eventually there's enough oxygen inside, the flame can go back inside, and then boom, built up pressure and blew. Cool. Okay, so this is not actually an explosion per se, but it does show how hot gases expand. So if a trapped gas expands, it wants, if a hot gas expands, it wants to push outwards. Well, normally, like in a hand grenade, it's inside of a metal container, but we'll just do it inside here where it's open. But you'll be able to see a major volume increase. It's going to go from a small little volume of bubbles. I have a bucket of bubble solution. You put a small little volume of bubbles, and it's going to get this big, huge, mushroom cloud, whatever you want to call it. So first of all, I got to fill up some bubbles here. So this is a standard methane gas. Okay, so we're just filling up. See the methane bubbles there? Throw a match in there, and let's have some fun. So again, that small little volume of gas made this big, huge, fireball thing, and we can do it again a couple times if you want. It's just fun. Again, all it's doing is making the fuel, the methane burns with oxygen, make carbon dioxide and water gas. So it's nothing really fancy there. It's just hot. The flame might be quite a few hundred degrees, so it's just going to be. Okay, so another fun variant of the methane explosion is just to do this. I'll just put some bubbles in here and I'll hold them in my hand. And light them. Now, why did that burn my hand? Again, that flame is like 600, 700, 800 degrees Celsius, whatever it is. Why didn't it burn my hand? Okay, well, notice it's not just bubbles and it's not just methane. It's got a lot of water in it. So my hand is really wet right now. So basically, the water has a really high heat capacity. The water absorbs a lot of the heat. This is what a lot of stunt people do when they do their stunts. Like they'll put on this flame retardant suit. They'll put this gel all over the skin to absorb the heat, and they'll have like a car crash or whatever, and this stunt person in the movie will be like fully on fire and the whole body's on fire, and then they'll kind of walk off camera and then they'll hit them with the fire extinguishers, put the fire out. But you can handle that for a while, the heat for a while, because it takes the water a while to absorb the heat before the water gets really hot. So this is just like 1 or 2 seconds. The water hardly had any time to react. So I'll do it again just to show it again. But it's if it lasted longer, it'd be dangerous. But in this case, it's not lasting long enough to really be dangerous. So here we go. Do the sorcerer hand thing, or whatever. I figured it got really hot there. This wasn't covered very well. It was at the top of the fire. So now, kind of interesting story of this, but I've been doing this explosion day for 26th year this year, I guess. And about 20 years ago, my wife, I came home from school, and Liz and I were eating dinner. Kids were sitting with us, and she looked over me and said, It was explosion day, wasn't it? I didn't tell her, well, I've been doing this ever since my first year of teaching, so I was like, no, I didn't tell her. How'd you know? And she looked and said, the hair in your hand, it's all gone again. She noticed that she noticed that every year, like, I burned the hair off my hand. And it doesn't really grow back anymore after all these years, but I have a kind of hairy back of my hand, but doing all these explosions, I lose the hair in the back of my hand. So she just kind of looked over at dinner and said, oh, your hair's gone on your hand. So it's kind of funny. Okay, so now the explosion. Again, for an explosion to work, you need some kind of a hard shell, like a hand grenade. You need some kind of a hard shell that can hold the pressure in, and if the pressure builds up, it can rip through and cause whatever damage that hand grenades do and stuff. So instead of obviously lighting a hand grenade off in a room, principal probably wouldn't like that. I'm going to make a much wimpier, but still kind of cool explosion. I'm going to take an eggshell. I took an eggshell, I poked holes in both sides and cleaned it out so it's nice and dry and it's empty. And I made a bunch of omelets and stuff then. So, and I'm going to take this eggshell and I'm going to put hydrogen gas in it. Now, if you remember from earlier in the class, we can make hydrogen gas with zinc and hydrochloric acid. So that's like 4 molar hydrochloric acid and some zinc. And I'll put the zinc and hydrochloric acid in here, and this tube system will allow the hydrogen to come out. I'll fill it in the bottom. I'll put a piece of tape on top to keep the hydrogen in. Hydrogen's a low density gas, so it'll escape out the top. So I'll now put this in here, fill it with hydrogen, and then I'll put it down here, pull the tape off, light it, and boom. So, okay, so let's just put the hydrochloric acid in there. Throw some zinc in there. And it starts, you can see it's starting to bubble and give off some gas there. And I can see some white, I can see from here some white gas coming out of there. That's actually some water vapor with the hydrogen. And just fill it up. And should be good. I'll turn it backwards. I'll just light it off here now. Okay, ready? Fire in the hole. Okay, so that was kind of fun watching the egg explode. And there's little pieces all over the floor here. So it's like an explosion, like an explosion of a hand grenade. Again, the purpose of a hand grenade, unfortunately, is to fling pieces out and obviously hurt people or damage property or whatever. So we saw these little pieces fly out, which they're not really dangerous. This is very low density, so it just kind of bounces off you. But you saw the basic principle of an explosion, just very wimpy. Now, that's similar to rockets. So rockets are actually a controlled explosion, like a kind of a continuous explosion where, like this egg, so the egg was able to blast material out all sides, kind of all directions. But in a rocket, you want to have the explosion pushed one way only. Like say that this little Pringles can is going to be like my rocket. We're going to go take it back there. We're going to fill it with hydrogen, same thing, same fuel, the hydrogen. And we're gonna, but now this is hard enough that it's not gonna tear, unlike the egg. But there is a weak point in the bottom. The cover is gonna be able to stay behind, so it's gonna if I light it on top, it's gonna blast into the air, and as it burns the hydrogen off, the pressure is gonna shoot out one side only. And if you know anything about Newton's equal and opposite reactions, if it's blasting one way, the force will push it the other way. So this is the basic principle of rockets. You have a big tank of fuel and only one little hole that can go out, which will push it the way you want it to go. So same type of thing. I'm just going to take the hydrogen, still generating some hydrogen there, and for reasons I'll explain a little later, I will have a blast shield on for this one. This is much more violent. There's a lot more. Again, compare the sizes here. The little eggshell versus this Pringles can. The Pringles can has a lot more volume, so it's going to have more explosion, of course. So, okay, so let's go blow this up. Yeah. What was that? Fire in the hole! Oh, I think that's where we're in now. Okay, so why I wear the face shield. My first year of doing this, back in the old high school like 26 years ago, I lit it, and I didn't have my face shield on, and I happened to, I used shorter matches, so I had like the regular, instead of these long matches, I had these little short matches, and I put my hand on there, and I just happened to have my thumb over the top of it. And when it went off, instead of going straight to the ceiling, it kind of rolled off my thumb and took a good chunk. I had a big flap of skin on my thumb, so I had like a spray of blood. And then it rolled off my hand and it came right to my face. Like it's one of those slow motion things you can't stop. You know, it's kind of like just goes, and I felt it like just nick my ear, and I felt this like hot rush of gas past my ear, and it's kind of nicked my ear a little bit. So I decided, let's get some longer matches and make sure we wear a face shield now, so you know it's not a problem. So that's why I do that. Okay. Okay, so let's get the big explosion now. So we're gonna have the liquid nitrogen bomb. Now, normally our explosions, it's because it gets hot. You know, the hot flame makes it expand and blow up, like the ones we did inside. But this is actually gonna be a cold explosion. It's gonna explode. When it explodes, it's still gonna be like negative 190 degrees Celsius. So we're gonna put liquid nitrogen in here and seal it. Drop it into a bucket of water so it has some heat to absorb. And as the liquid nitrogen evaporates and evaporates and evaporates, it's going to build up pressure. Eventually you just, it's like a 12-gauge shotgun going off. So, so I need to put some, first of all I need to put some water in here. So I have like a heat source to evaporate the liquid nitrogen a little bit faster. Then I need to go over to the liquid nitrogen and fill it up. Use a funnel here. There's the liquid nitrogen evaporating away fast, boiling away, and I will just put it in here, and ready?
Ready.
Good? Alright, cool. So, fire in the hole. Oh, run! In there. Okay, so we have little shrapnel everywhere. Little pieces of that bottle are just everywhere here. But it's interesting again, everything was still cold. The liquid nitrogen is evaporating, but it's still super, super cold. So like all these pieces, shrapnel, are covered in frost. Kind of weird. Now next, we're going to try similar, but it's going to be a little different. Instead of just blowing it up, we're going to put it in the water and put this bucket on top. And if it works properly, the bucket will go flying, 40, 50, 60 feet in the air. So we can use the energy of this, again, as a rocket engine. A rocket engine is, again, something where the energy blasts out one end, not the sides. So the bucket, hopefully, we've broken buckets before, but hopefully this one holds. So same thing, gotta put a bunch of water in there. So give some heat, sort of thing. So gotta put the liquid nitrogen in here. Go, plenty of liquid nitrogen. I squeeze it, so I have, it's really cold. Nobody told me this was going to be cold. Squeeze it, so I have a little bit of a fuse, throw it in there, put that on, and run. Oh, it's going to miss. Yeah. And run. I forgot that I had to watch that so I didn't kill you. I knew it looked like a good miss, so. We got a little dent there. That's okay, it's still holding.
Got a dog's attention there too. Hey, pup.
That was fun. Let's do it again. So I'll put the water in there. The bucket survived. Always a bonus. And sometimes the bucket shatters. Right. Freeze it. See you later. Throw it in there. Bucket. Run.